Hello, and welcome to today's lesson on Standard 1.1 in 8th grade. This is going to cover topics under that standard in 1.1 on our standards, but it's also going to cover topics under the Study Island lesson called Equations and Formulas. This 2 parts for that lesson. I've made 2 videos. This is the first part of 2. And this one we're going to deal with writing and solving equations. So make sure that you look at both of these videos before you go on and work in that Study Island lesson. And as always, just remember you can pause, fast forward, rewind as you need to in order to write good notes. Writing good notes is an excellent thing and something that you should be doing as you're watching these lessons. And you can even pause at the beginning of the question, work the problem out, and then see if you get the same answer as I do, and that way you can kind of get a gauge on where you're making mistakes and where you're getting everything right. I'm so glad that you're joining us today, and let's go ahead and look at some notes.
Questions in this section are going to ask you to write an equation from a word problem. So just some tricks on when you are writing these problems is you're always going to have a number that it's equal to, and that's typically going to be your total number. Okay. And then you could have addition or subtraction. You're just going to have to kind of look at the problem and look for those keywords that mean addition or subtraction. And typically, though, when it's addition, your term with the x will be first. It could be either way. I mean, you can add in any order. And typically, when you have subtraction, your term with the x is last. It's just kind of the way that the problems work out most of the time. But you have to, for those few cases, you have to pay attention to. And then the number in front of x is being multiplied by the x, so you're going to want to look for words that mean multiplication. So, per number, miles per gallon, that would mean multiplication. You could also have each. Those keywords are the words you're looking for to see which one you're going to put in front of x. And then the number by itself, you're just adding that one time. So that's typically your one-time number. This cost only happens once, or you initially start out with this amount. Initial or starting number. And that can go here too. All right, so make sure you have this copied down so that you can refer to it when we go into our questions. On Fridays at the ballpark, a cup of soda is $4. Each refill is 70 cents. Last Friday, Tanya spent $8.20 on soda at the ballpark. Write which equation can be used to find x, the number of refills she bought. Well, when you buy soda, and then you're going to add on the cost of each refill, so this is going to be an adding problem. And I went ahead and already copied down the format that we typically use, and we're going to see that it works. And so the total amount that she spent was this $8.20. And so we also have $4.70. Her initial cost for soda was that $4. So that happened just one time. So that's going to go by itself. And then each refill is 70 cents. So that means if she refilled 5 times, you would take that 5 times 70. And so that means it's going to be times our x. And x is the number of refills. So you're multiplying this 70 cents times whatever number of refills that we don't know. And that's going to be our answer. Now here they just don't put on the extra zeros in our answer just because they're not necessary. So that's why it looks a little bit different. So they have 8.2 equals 0.7x plus 4 as their answer, which is letter C. Billy Sue's Barbecue had their grand opening this year. Each month thereafter, they have had steady profits of $1,800 per month. If the restaurant has made $19,800 in profits, which equation can be used to find X, the number of months since the grand opening? So here I have two numbers in the problem. So typically, the notes we took show us that we typically have 3. So that's a clue that this might be just a little bit different. First off, I see that the restaurant has made a total of $19,800 in profits. So I'm going to put that where the total number goes. And then I see that it made a steady profit of $1,800 per month. So there's that per. So for every month that makes profits, I would multiply that times the 1,800. And so I don't know how many months, so I'm going to use X to signify that. And then, there was no initial profit number or starting profit number. It was 0. So that's why there's nothing being added or subtracted at the end. And so that makes my answer C. Ronnie recently bought a car for $37,000. Her research shows the car will depreciate an average of $1,400 per year. Which equation can be used to find X, the number of years she will have owned the car when its value is exactly $32,800? Okay, so this one here, you have to know what the word depreciate means. Depreciate means that when you buy something brand new, as you use it and you put wear on it, it's not going to be worth the same amount in a year just because it's considered used. And so depreciate is the amount of money you lose off the original amount. So this is saying that as they put wear and use the car, it becomes less valuable by $1,400 per year. So depreciate means that you are losing money. So that means this one's going to be a subtraction problem. So I'm going to go ahead and write down my notes for subtraction to see if I can fill things in here. So it wants to know how long does it take for the value of the car to be a total of $32,800? And so that's going to be where I'm going to put my total number. The car initially started out at $37,000. That was my starting number. So it's going to go one time at the beginning with no X. And then per year, that means that for every year, it's going to go down 1,400. So I'm going to multiply that times the number of years, which is what I use to tell X. And so that's going to be my equation, which is letter A. Now we're going to be looking at linear equations, and linear equations are very similar to the word problem equations, but only now we have a y and an x in them. So you're going to have, it's always y equals a number x plus or minus a number. And so this first number is our slope number. You can either count that rise over run, but in this equation, we're going to have to subtract y numbers over subtracting x numbers. And then the number at the end that's being added or subtracted by itself is the y-intercept number. And it's the number where the line crosses the y-axis. Or if you're given a table like you are here, it's the number that has a 0 for an x-coordinate. So we're going to go ahead and write down our blank piece so that we know we need to fill in numbers. And since it's a table, and we're going to look for the y-intercept number, and it's going to be the y number beside an x that's 0. So here's my x that's 0. And beside it is the 3. And so that's y number of 3 is going to be my y-intercept number. And then the slope number, I'm going to have to pick 2 of them. And you could pick any two lines. Some people like to pick the first and second one. I like to just look for easier numbers to work with, so I'm going to pick those two lines. And then if I look at my formula, I subtract y's on the top. My y column is right here, so I'm going to take 3 minus a negative 1 over, and then I'm going to subtract my x numbers on the bottom. And just be careful, I started with the 3 here, so that means I have to start with the 0 on the bottom. I just have to be consistent. So I'm going to take 0 minus 1. And then I just work that out. 3 minus a negative 1, that changes to 3 plus 1, which is 4. And then 0 minus 1 is negative 1. And then 4 over negative 1 simplifies to negative 4. And that's going to be my number in front of x. And that makes my answer B. The last type of problem you're going to see in this section is solving for x. And this is a two-step equation because it has two numbers on the same side as x. So if I draw a line down my equal side, and that divides it into the left and right side. And so your first step is always going to be, in a two-step equation, is to move the number that's being added or subtracted. So here I have 3 times x minus 3. I'm going to move this subtract 3 first. Okay, the opposite of subtracting 3 is adding 3. The opposite of negative 3 is a positive 3 is another way to think of it. So I'm going to have to add 3 to both sides to keep it balanced. So I add that 3 to both sides. Here, negative 3 and positive 3 cancel. So I'm just left with 3x on the left side. And that's going to be equal to 15 plus 3 is 18. Here, this is 3 times x, so I'm going to divide both sides by 3. And those cancel. And x is equal to 18 divided by 3 is 6. And so that's going to make C my final answer. And remember, you can always double check that by substituting the 6 back in for the x. So I would take 3, and now instead of writing x, I'm going to put the 6 minus 3. And then I want to see, does that equal 15? So here, 3 times, follow order of operations, 3 times 6 is 18, minus 3 is 15. And 15 is what I was looking for, so it checks out. And so that's my answer too. Thank you for joining us today, and I hope you learned something new.